Okay, so we left off here where we have figured out the P wave arrival time and the S wave arrival time. And what we need to figure out next is the time difference. What is the time between the arrival of the S and the arrival of the P? And we need to subtract. I'm reminding you now that we are on number 2 here. Calculate the amount of time that elapsed between the arrival of the P and the S at each station. So we have to subtract time, and I have a little set of instructions here to help you out. Some of you might be able to do this without these instructions, but if you really have no idea how to do this, then you can just follow these 5 steps. So step 1 is subtract the hours, and remember we have hours, minutes, and seconds, each separated by a colon. So 1 minus 1 is 0. Done. Then it says subtract the minutes. 9 minus 4 is 5 minutes. Okay, so all is good. It says if the minutes are negative, well, they're not. So we can ignore this for now, but later we're going to have to look at this. Then subtract the seconds. Well, 5 minus 30 is negative 25, right? So the seconds are negative 25. So now we have to follow this simple set of instructions. We add 60 to the seconds. So we add 60 to negative 25 and we get 35. And we subtract 1 minute from the minutes. So subtract 1 and we get 4. So the answer is 4 minutes and 35 seconds. Now, again, this is doing it without really understanding what you're doing. It's base 60. Some of you can figure this out by maybe even picturing a clock in your head. One way to check, though, is to take 4 minutes and 35 seconds and add it to 1 hour, 4 minutes and 30 seconds, and see if you get this number right here, which you should. So our S minus P time difference is 4 minutes and 35 seconds. Let's go on to KMBO, the second seismograph station. This one has its P wave and S wave indicated here. They're a bit different than the previous one. And again, we need to figure out the time that each of these arrived. So why don't you put this on pause for a second and see if you can figure these out before I tell you. So here is where the first one is a little bit shy of this tick mark. The second one's a little bit past this tick mark. So you might have to make some estimates. Go ahead and try that. Okay, so here's the answer for the P wave. It's 1 hour, 8 minutes, and 48 seconds. And I got 48 from 108, 10, 20, 30, 40, but not quite 50. So I said 48. You could have put 49 or 47 or 46. It doesn't really look like it's halfway between to be 45. So we're just estimating. So that's my estimate, 108.48. And over here, my estimate is 1:16:52. So we're not quite halfway between the 50 and the 60, which would be 55. So I'm using this number right here. It's not going to make a big difference. And really, my concern is that you know how to do this whole procedure, not so much that you get the exact number to the second. So we have our P arrival time at 1:08:48 and our S arrival time at 1:16:52. Once again, we have to subtract and figure out the difference between these two. Now this one's a little bit easier because 52 seconds minus 48 seconds is 4. 16 minutes minus 8 minutes is 8, and 1 minus 1 is 0. So that one doesn't really require thinking too hard, except realizing that these are seconds and these are minutes. So we have 8:04 for our time difference. This last one, Guam, I'd like you to try this one on your own. Okay, here's the P, here's the S. Follow what we just did and see if you can fill that chart out on your own. The next thing after the chart is done is to use the P and S wave time travel graph, which is this graph right here. And we're going to use it to find the distance to each earthquake epicenter. I'm going to show you how to do it for those first two, and then you're going to do Guam on your own. So what is on this graph? Well, I showed you this in the last video. This one's a little bit different. This has distance from the epicenter in thousands of kilometers. So 10 to the 3 is 1,000. So 1 really means 1,000 kilometers. 2 means 2,000, 3 means 3,000, etc. And then on this side, we have the time for the waves to arrive. So remember, the P wave has this essentially velocity curve, okay? And then the S wave is a bit slower. It's up here. And really what we know is the time between them, and we want to find out the distance. Now, because my eyes have trouble with this graph, I am adding some additional red lines at these major points, 1,000, 2,000, 3,000. It helps guide my eye. So let's pretend that we are 8,000 kilometers from an earthquake epicenter. What does that mean? Well, here's the P wave, and it's traveling, and by the time it reaches us at 8,000 kilometers away, it has taken about 11.5 minutes. Remember, if we were at the epicenter, there would be no time. It would be instantaneous, but it takes time for that wave to travel through the earth. Okay, so it took 11.5 minutes to reach us. The S wave took quite a bit longer, about 20.5 minutes to reach us. So remember, what we know when we look at the seismograms is this difference right here. The difference I'm showing with this purple arrow, which happens to be about 9 minutes. And we use that to find the 8,000 kilometer distance. How do we do that? So we know that there are 9 minutes between the P and the S wave, and we're going to draw our arrow to be similar in length. Now you can do this with a piece of paper on your lab. And then we're going to slowly move the arrow across the graph, keeping the bottom of the arrow on the P wave until the top of the arrow is at the S wave, right here. And once we get to the right place, we know, okay, the P and S wave are now separated by 9 minutes. And then we drop down and say, oh, we must be 8,000 kilometers from the epicenter. So that's really the way this works. So let's do this with the two that we have already figured out. We're going to start with the first one. And remember, the time difference between them is 4 minutes and 35 seconds. So 4 minutes and 35 seconds. The arrow here is about that long, and we're going to move it up until we get to the point where these two curves are separated by 4 minutes and 35 seconds. I'm going to say 30 seconds. And it looks like it's right at the 3,000 kilometer mark. So this station is 3,000 kilometers from the epicenter. We don't know the direction, but we know it's 3,000 kilometers away. Let's do the next one. The KMBO site is 8 minutes and 4 seconds away. So I'm going to round that to about 8 minutes because on this graph it's hard to say what 4 seconds are. And again, I'm going to move it along until I see where it separates the two curves by 8 minutes. You can do this by taking a piece of tracing paper or notebook paper and marking off the 8 minutes and then sliding it along the curve. That's what I usually have students do in class. Now this one is not quite at the red line. It's not quite at 7,000. It's about 6,800 kilometers. So I'm going to put 6,800 kilometers in there for that answer. Remember that Guam, this last one, is up to you to do. And then finally, we're going to put some circles on our map. We're going to use map 1. Make sure you see that it says map 1. And here are our 3 stations, 1, 2, and 3. And we're going to draw circles. Okay, so let's start with the first one. We have a 3,000 kilometer distance. So here it is. This is the station. And here's our map scale down here. This is very important. So what you're going to do is this. If you happen to have a drawing compass, you can measure from 0 to 3,000. And then you put one point on here, on the circle, and then you draw a circle of that radius. Now, of course, it's not going to be flat on the page like that. Really what you're doing is something like this picture here, but it's hard for me to show in 3 dimensions. And so in red, I've drawn that circle. So somewhere on that circle is our epicenter, according to the information from this station. If you don't have a drawing compass, you can make one at home. You can simply take a pencil, tie a string to it, put it in the center of the paper, of the map. This would be your map here. And make sure that you stretch it so that it's the correct distance. So for example, This right here equals 3,000 kilometers on the scale, and then draw your circle. It's not going to be as perfect, but it's better than nothing. Let's do the next one, KMBO at 6,800 kilometers from the epicenter. So here's what we have so far. Now we have 6,800 kilometers, so we need to widen our drawing compass. We put it on the KMBO point and we draw our circle, which here I've done in green. And don't worry if it goes off the map. Now you can see we have two places where these curves meet. Once we have our third one, Guamo, it should intersect either up here or down here and show us where our epicenter is. All right, so hopefully that's a lot of help to get you through this activity. This is just part one, because part two, you're going to do this whole thing again with a different set of data. Okay, so Guamo, which is Guam, you're going to do on your own. Finally, once you have all three of them, they meet, you're going to make a point where they meet and label it epicenter. Following that are a series of questions. The first one has to do with what characteristic of the seismograms is allowing us to determine which site is farthest from the earthquake and why. So think about that. What are we looking at on these seismograms? And it has to do with the P and the S waves that tells us whether an earthquake is close or far if we compare two stations. The next question has to do with some tectonics, and you have to look at your tectonic map for this. Given the epicenter location, and assuming it's on a plate boundary, what are the two tectonic plates on either side of this boundary? How are they moving relative to each other? And this you would only know by looking at your tectonic map. This is not information that the earthquakes tell us. And then what kind of boundary is this? Also, something that you should find on your plate tectonic map. And then how could we determine which plate is subducting beneath the other? So just think about this question. How would the epicenter location on a map help us know which plate is going down? And then finally, we have this last part, which is definitely tricky, so I want to go through this. I'm going to blow it up here. And again, we have a little page number error. So now we want to find out, when did the earthquake actually happen, right? We recorded the earthquake. We know we didn't record it at the time it happened because it took time for the waves to get to us. How do we figure out when the earthquake actually occurred? So we'll start with the first one in Tibet, and we're going to use the numbers from this column right here, the P wave arrival time. So you're going to just take these numbers from earlier and put them right in here. Now you should also have Guam because you've done that one. All right, so that's simple. You just take the arrival times from page 43, first column, put them in there. Then the P wave travel time to reach the station. We haven't figured this out yet, so let's look at this first one. Remember that we determined that we were 3,000 kilometers away, and this is where the arrow was the correct distance between the P and the S waves. So let's look at this intersection of the P wave with the side scale. Remember, here's the P wave traveling. Okay, it took about 5 minutes and 40 seconds for it to reach us. Right? So this is the time it takes for the P wave to reach us. And that's what we're going to put in this one. Okay, more next in the next video.